This is part 2 of section 3.1. We just talked about the various definitions for statements and we talked about negations. Now we're going to talk about quantifiers. These are the words all, some, and no, or depending on how it's written, it might be none. So if you see these words, you have a quantified statement. And by definition, it's a statement that contains a quantifier. Okay. So we have some equivalent ways of expressing quantified statements. Now, we had these right here, and you might say something like all A are B. And an equal way of saying that would be there are no A that are not B. So examples in English, all poets are writers. The equivalent way of saying that would be that there are no poets who are not writers. Okay? So these have what we call is the same truth value. If this is true, this is also true. If this is false, this is also false. Okay? If we have some A are B, the same way of saying this would be there exists at least one A that is not a B. Okay? So some people are bigots. At least one person is a bigot, okay? We can't say all are if we don't know that all of them are. But if we know at least one is, then we can say some. If we know some, we can say at least one person. No A are B is equivalent to all A are not B. So equivalent ways of saying for here would be say no common colds are fatal. And the same truth value would be all common colds are not fatal. Some A are not B. Not all A are B. So some students do not work hard is the same truth value as saying not all students work hard. Okay? If you think about it in English, if you think about these various statements, you can play around with it and see that these are equivalent statements. Now, where this gets a little bit tricky is when we start going to negate these. Negating quantified statements. All A or B. It is tempting to change all are to none are, but they are not equivalent statements. What you need to think about is you want to find the minimum requirement that would make the original statement false. Now, obviously, if all A or B, then no A or B is going to be true, but that's not the minimum we need to prove that statement false. If I say all A or B, all I have to do is to find one that is not true. So all A are B, the negation of that would be some A are not B. Okay, so all cats have fleas. To make this not true, all I would need to find is one cat that does not have a flea. So some cats do not have fleas. All I need is one to prove this false. And this works the other way too. If I have some A are not B, its negation would be all A are B. Now, if I have some are, then I have some A are B, its negation is no A are B. Some cats have fleas, and the negation is no cats have fleas. Okay, now how can you remember this a little bit? Notice that the two some statements are not, that each one of these cases has a some statement in it. And each one of these has a no or not statement in it. So if I have all, I need a some and a not. Here I have a some, so I need a no or an all. So no, that gives me the no negation here. No A or B. So each one has a some and each one has a no or a not. Okay, now we can look at this with a Venn diagram. I told you that there is a very close relationship between sets and logic. And we can look right here for this statement. All A are B. This can be represented with a Venn diagram like this. All cats have fleas. Here are all my cats. And they are entirely inside the fleas. Okay? Now here, some A are not B. You can represent this here. All I would have to do is to find one cat that does not have fleas and to make this statement false. Some A are not B. Over here, we would be talking about this area right here. Now, if all cats do have fleas, everything would be in this region right here. So it is possible, but that's not the negation. All we would have to do is to find one cat to make this thing false. One cat without fleas to make this false. Okay. Some A are B. So some cats have fleas. That would be talking about that region here. Okay, because some cats have fleas, so there is something in the overlap. No A are B. No cat has fleas. Here's my cats, here's my fleas. There is no overlap. Okay.